Hi, class. I want to do one more supplemental lecture before we meet on Tuesday. I know we've had a little bit of a rough start. Unfortunately, that is how the fall quarter seems to always go in terms of making sure we have access to the virtual machine and other resources in time. I promise you, it will get steadier. You will have more lead time and you will have more ability to work on these projects. I've seen some of you using Slack, and that's really great. I've already seen some of you submit assignments, and I'm just blown away. What I did want to talk about were some sort of hidden curriculum items of learning how to use data and learning how to do statistical programming in general. And one of the things that is really important, but you're never really taught explicitly, is file structure. And I just want to walk you through an example of how I construct and set up my files for my projects. So this is week 1 for our data. And the exercise that we're going to be doing later today in class is called animal fights. And the way I set it up is I try and have one folder for a giant project, and then I break out the subdirectories into specific tasks. So raw data, I actually like to keep raw data that I receive from, say, an external source, or I downloaded off the web, and that will never change. With the idea being that you want your code, that when you write code, you want things to be something called idempotent, meaning that when you run it again, your results are not going to change as a function of how many times you run it. So one of the easiest ways to sort of start and develop that structure is to make sure that your programs start with raw data and follow a continuous and consecutive pipeline such that you will always be able to go from the very first step of your data and then go into whatever your exploratory analysis. Generally, what I like to do is I like to split my statistical programming into data cleaning and then have an exploratory data analysis tab. That's where I do more sophisticated analyses, or because generally once a do file starts to get too long, it gets time consuming to run. It's hard to understand what's going on, and you often will find yourself scrolling back and forth. So with that, I want to walk you through some of the data cleaning exercises that I've done in preparation for your assignment. I think there are some useful tools here. You might not have that many opportunities to use them in this course, but I think it's really worth knowing. So with that, we'll talk a little bit about how we clean this data. So the first thing that I talked about is that when we load a data set, or the first thing you want to do is clear the environment. And that means that in case you had anything previously loaded, it's not going to be lurking around in your stated data set. And that goes back to that idea of idempotency that we talked about. That if you're always starting from a blank slate, you don't need to worry about being able to replicate your results in the same way. The next thing that I do is I check the current directory of my code. And what that does is it lets me know the relative path. That is more just for whomever's using my code. If you're using it in the way that it's intended, you will know that you're in the programs file, and that if I go up one directory from this, I can be in my animal fights data set. And if you haven't seen this notation before, this is called a relative path. So it doesn't matter if I'm on my current machine or if I'm on my virtual machine. If I download, say, this animal fights data set, all of this path will change, but the relative position of animal fights and programs and the raw data being living in the same place, that will not. All right. I was going to pause for questions, but I'm talking to myself. The next sort of nice documentation feature, and this is actually one of the things I really like about Stata compared to almost any other language, is that you really can sort of leave yourself breadcrumbs and metadata in your underlying .dta file. And so one of the things that I wanted to make sure that you were aware of when I created this data set and created this exercise is that I created it and where this data was coming from. So I can actually leave notes in a .dta file. So it's a very straightforward command. And just as always, when you want to learn more about a command, you can type help and the command name, and it will give you use cases, commands. So for instance, I could leave a very general note about the data set. That's what this highlights. Or I could also pass a variable name as well. That's what this argument in brackets indicates. And I can also just see what notes someone has left for me by typing in this command, or if I wanted to say get rid of one of them, I also have these affordances. So I'm going to create my notes. I'm going to create my notes. And when I run my notes command, we can see exactly what I typed in. And this is going to persist so long as we save the underlying data set. The other feature that I really want to highlight about Stata is there are these things called labels. And so when you look at the variable toolbar, you can see that every variable has a name and a label. Often they're the same, but often they're not. So for instance, record number is both the same in the name and the label category, but age is age, and the label is what is your age. And what's nice about this is, again, this is actual survey data that we're using, and we're able to keep track of the underlying survey questions. Now, sometimes it's nice to have that information, but obviously if we have a variable named, what is your age, question mark, that is a lot more typing we have to do. So what we do is we have this sort of crosswalk between names and variable labels, and we can change them as well. And if you want to see what all of these individual labels are, you can use the label list command, and that will let you know what all of the different variable names are and how they map to the underlying values that we'll talk about a little bit more. And sometimes, again, you might want to create a specific note with regards to variables. If you drop things, if you add things, or if you say, put a max or minimum value, it's really helpful for other researchers to be able to have access to this. So one of the things that I wanted to make sure that everyone was aware of was that the data set that YouGov collected, that they collected only binary gender characteristics. So individual survey participants were either labeled male or female, that there were no other options. And I just want that to be noted for the sake of, we didn't drop anyone, we didn't exclude anyone. This was just how the data was originally collected. The other things that, again, really nice about Stata, you've got this describe command and codebook. These are things that you're not going to hear about that often in other courses, but this is almost the most important part about data science and statistics, is that you actually understand what you're doing and what the underlying data is. So I'm going to emphasize this quite a bit during the course. And you can just read these more carefully in class, but the data set that we're studying is a survey of YouGov participants who were basically asked which animals they think they could beat in a fight. This was part of a fun, content marketing piece almost of what they were doing. But I found it a really interesting data set, and it's a nice example of what we can also do with psychometrics and other tools. But there's a lot of demographic characteristics, and I want to simplify this just a little bit. So for instance, let's take this variable education underscore W8. That is a little bit hard for us to understand. We know it's an education variable, but maybe let's just make it something simpler. Some college plus, 4-year post-grad, and no high school. So let's create a variable called college, and just we see that there's a natural numeric ordering to these variables, that 1 is the least educated, 4 is the most educated. I'm going to create a simple variable called college that is just checking if this education underscore W8 file is greater than 1. And why don't we do that right now? And the things that I also want you to notice when we change this, generate this college variable, that we no longer have any of these labels. Sometimes that's nice, other times it might not be. I think it really depends on your use case. The other thing is that sometimes you might want to rename variables more broadly. So we've got this animal fight 1-1 variable, and when I look at that immediately, it's not clear to me what the variable means. In this case, when we call the codebook function on it, we can see that it's an animal fight with a rat, and the associated 3 values are: I could beat this animal in a fight, I could not beat this animal, or I don't know. Again, it doesn't necessarily map to me that 1 means you won the fight and 2 means you lost it. It could have been no, yes, 3 don't know, or a completely different scale. So I do want to emphasize that these things don't necessarily map to some sort of ordinal context. But these are really useful. So the other thing that we can do is we can just rename these variables. So the command, again, you can go to the help file, rename, and learn a lot more about the different syntax options. And there are many that are quite powerful. I'm just going to show you 2. One is I can go in and type rename the variable of interest and its new name. So instead of animal fight 1-1, it's going to be fight rat, and we're going to do that here. I can also rename a bunch of variables at the same time. So we've got 15 different fights, and I can just use this parentheses argument, list all of the old variables that I want to rename, and give the names of all of the new ones. So from fighting cats to fighting geese. And you put both in parentheses, and we're going to do that right now. And what happens is when we scroll down is that the underlying variables also change. And they retain their labels, which is also nice. So now when I look at them, even if I'm using the variable or the label, I know what I'm fighting. or I know what the survey participant is doing. The next piece is I want to simplify this analysis a little bit more for us, that I don't want to deal with this don't know category. I just am mainly interested in, does this person think they could win a fight with a particular animal? And so what I want to do is I want to go do something called binarization, where I only want to see if a variable is equal to a particular value or not. In this case, it's I could beat this animal in a fight. And so what this little snippet of code does is it goes through all of the different variables that start with fighting a rat and end with fighting a goose. So that range of 15 variables, it goes through, it creates a variable called wins with the associated variable name, and then it checks in this variable, animal fights, or fight rat, did this value equal 1? And then we just we repeat the exercise for all of the 15 fights. And let's do that right now, and you can see what it looks like. And so we'll code book win. And you can see that what we have right now is we have 2 unique values now. We no longer have this don't know case, but we've got, and we still have our I could beat this animal in a fight as a 1 numeric value, but currently our 0 is unlabeled. And we'll leave that as an exercise for class. But what I want you to think about is what do we want to call this and what seems appropriate. But generally, these are like things to do to make your data set more accessible to you and your colleagues. The next thing we want to do, and I want to highlight, is it's really nice to understand how students or how individuals are performing on single survey items, but sometimes we just want to add them up. So how many animals could a person beat in a fight? And so we have a bunch of egen commands that are really useful for things like this. Now, what we could do is we could create a variable called fight count or something like that, and do wins fights cat, wins fights chimpanzee, plus, etc. But that's tedious and laborious, and it's in case we say do another survey, it gets kind of tricky. So say update with a new animal or a new item. But what we could do is we could use this sort of star expression, which this star is what's called a wildcard, and it means it basically look for all things that match the preceding text from here on out. And so what this will do is look for things that match this wins fight argument and include all possible variables that satisfy this criterion. Okay. And we can see that this sort of maps to our intuition of what the possible range of values could be. There are only 15 fights, so at most you would see 15, a score of 15. So that's good. And as I mentioned before, you can also create labels for these things as well. So if you see some score, you might not necessarily be sure what the underlying question was or what the research data is. You might think this is a test, or you might not be sure how it relates to the other variables. So what we can do is we can create a label for it. And so this is some example syntax. You tell the label command what you want to label. In this case, it's a variable, which we abbreviate as var. We identify which specific label we want to, which specific variable we want to label, and we state the specific label we want to create, which is called how many animals you could beat. So let's just scroll down and check that's what it does. How many animals? Some score, perfect. And the other thing that's sort of nice is we can create individual labels for values as well. So this is a bit of a toy example, but if a person didn't think they could win any fights with an animal, I want to call them a pacifist. And if they think they could battle every animal on this list, including grizzly bears, I want to label them as a pugilist or a fighter. And so that is the exact syntax that we're going to use right here. And so what first you need to do is create a value label, a set of value labels. And the next thing you do is you actually have to assign that to a particular variable. So the way that syntax works is it's label value var name, which in this case will be some score, and then it will be the label we defined, which is fight record. I think that's correct. And let's check what happens to our sum score. Perfect. So again, this is a little bit of a toy example, but I think it's helpful to understand what's going on. One last thing that I did want to talk a little bit more about is the different tools you can use when graphing. We're mainly going to be talking about univariate statistics this first week, but there are still a lot of powerful ways you can combine that with graphing commands to just get a better understanding of your data. So for instance, there's something called a box plot, and what we can do is use this command graph box sum score. And what these plots represent, if you haven't seen this before, if it's been a while, is that a box plot is a nice way of articulating the range of your data. So this middle line corresponds to the median or 50th percentile of your data. The ends of this box corresponds to the 25th and 75th percentile respectively. And the tails or whiskers correspond to the 5th and 95th percentile of your data respectively. And anything beyond that would be considered an outlier. But often we will want to do comparison across groups. And while we're not going to talk about the actual statistical inference right now, it's very useful to understand how to do that. And create those sorts of visuals. So for instance, if we wanted to understand, say, the difference in sum scores by gender, we have this option of by, which will generate that. We also have other ways of performing the same command. And so we also have this one called over. And you can see that these are very similar commands, but on one, you generate separate plots. On another, everything is on the same plot. And the respective when you want to do one versus the other, it depends on what sorts of visualizations you want to highlight. But I do want to mention that creating good visuals is probably the most important part of communicating your results effectively. I can personally attest that when I tweet an article, my co-authors and I really think about how can we communicate powerful visuals that sort of encapsulate a paper? And so I really want to emphasize that this is something that you should take time to do, think about, and iterate on. With that, I think we reached the natural stopping point. I'm really excited for our first class, and I hope you all are having a wonderful first week. Take care.